So welcome everybody, and join us this hour. You probably don't know, but we made a lot of yoga lessons and cooking lessons, and of course meetups, technologies meetups. So for now, this is what we are intending to do now. Matrix Global is around, let's say, Eastern Europe, and we are part of the Matrix IT that lead in Israel the IT companies with more than 10,000 employees. And we are really happy that you are joining us. So enjoy. Roni Keren is our John Bryce CTO, and I'm sure you will love it. So, Roni, welcome and enjoy, everybody. Thank you very much.
Thank you. Okay, so you can stop sharing and then I'll take over.
Yes.
Thank you.
Yep.
Okay, right now I opened my video. It won't be long because I don't want you to suffer so much. But I will spend some few seconds about myself so you'll get to know me before deep diving into our topics today. So let me just share the widescreen for a second. And I will write my name and email. So my name is Roni Keren. And I'm, as Judith mentioned, I'm the CTO of John Bryce Training Center, and here comes the pretty interesting part. Basically, a training center has got nothing regarding high-tech services or high-tech products. So why do they need any CTO at all? So I want to tell you about that because it has a lot to do with our lecture today. Basically my job is to visit companies, provide some help and consulting, and of course map any knowledge gap in those companies. So I get to meet all the R&Ds and the R&Ds managers and the architects and the system analysts and you name it. And since it is happening in Israel, and as you know, Israel really likes to try stuff. Next thing that is pretty much interesting developers today, or on the other side, I get to know which technologies are counted as old, or they should really vanish. And I take all this information back to John Bryce Training Center, and this is how me and my friends and colleagues are capable of providing gaps solutions with courses. So this is important for our meeting today because I can tell you about, and this is what I want to speak about, those technological, really dramatic changes that I'm seeing today. And this will probably be quite wide covering topics that are already being seen in the industry today and being implemented. And we'll discuss those, how we shift to them, and how we going to continue with this in the future. But also, we will spend some time talking about some innovative parts, which means that this part holds technologies which are about to give their bursts and to really expand in our high-tech industry. And these are really game-changer technologies. Means that not only the high-tech industry is going to be really different after they will make those huge steps, it will also change our individual lives. We've seen some of those happening in the last decades, but we are at the beginning, and I hope you understand that. Okay, so from some reason I'm not sharing anymore. Wait a second. I will continue sharing. Sorry about that.
You can share now, Roni, but I cannot see your presentation. So
because all you need to see right now is the whiteboard with my name on it.
Okay. So I thought it's
so everything is planned. It's okay.
Okay, sorry.
Now, it's okay. Now, my email, by the way, Keren, you can write it down. Okay, so I basically work with Java since 1999, so it's pretty much time. 4 years after this really popular language was born. And since Java played on the backend ground, then this is what I've learned and focus at. So I can talk about the evolution, architectural evolution of backend solutions today, which are mainly what we do in the services industry and in this huge thing that we call internet. And this obviously will be our focus today. So okay, now Zamir, you can't wait. So we'll start with the presentation, and let's go. So basically, I will switch to the whiteboard from time to time because I really want you to understand these architectural assumptions made and the dramatic changes that are being now occurring. So we have to understand some architectural parts, and I will use this whiteboard to draw some stuff in some occasions. So let's start. First thing, something that is already happening, but we'll deep dive inside just to see what's happening and why and where is it going to be in a few years. We came from what's known today as domains or monolithic services to systems. Means that we are talking about something like 20 years of backend development started in 1995, beginning of the real internet, until basically 2015, something like that. So it's pretty much time. Now, those are the days of JE and .NET, and I would like to use the whiteboard for a second just to make this clear. If you think of it, there are some really great stuff that we invented back on those days, even though it was pretty challenging. And basically, end of the story in this architectural ongoing planning was coming up with what's known as the three-tier model. Now, what is this three-tier model? Three-tier means that we've got 3 tiers that are handling our clients' requests. So let's just put those names on those tiers, and it will be much clearer. So first tier, which is very important, known as the web tier. Web tier is responsible for the community with our clients, with online devices, basically communicating over the internet. Now, since the internet is the World Wide Web, we really want to do business on it. So we have to be exposed on it. The web tier is really important. Now, today we do it, with REST, but we've got a long history starting with XML and even nastier stuff like IOP and RMI and stuff like that. Anyway, shifting to the next tier, we're talking about a business tier. This is where the magic happens, means that this is where we do our business logic, and this is where we run our decision making. This is our products, basically. Okay, this is what we sell. Now, usually we have to use databases or third parties, right? And these are all data providers that might be external from our domain. So it's another tier, not necessarily ours, but it is something that we must use sometimes. Now, basically, those 20 years I'm talking about looks like that, okay? If I'll take another rectangle here and place it here, this is what we used to call, and I will soon say what we used to call JE, Java Enterprise Edition, or .NET, its competitor. So these two amazing standards actually were the service platform for all the IT enterprise industry in the 2 last decades. And I'm talking about telecom, I'm talking about fintech. So it's a huge industry. Now, these are basically gone right now. Those standards are now being closed. Why? So the problem with this is something that was good back then. When I installed any application server, JE application server, or Windows NT application server, I got plenty of services as part of this installation. I got all kinds of stuff which I probably need. For example, this part here is responsible for caching data when we reach databases, okay? Caching is important. Well, we'll talk about this caching issue later on, and we'll discuss if it's so important today. We probably want to have some message queue, asynchronous messaging. So there's another service we got with the installation. We probably want to do some, I don't know, transaction management. So we got some tools to manage transactions. So basically it's a great thing because all I have to do is install it, and then I can focus on my services, which gains all those platform services easily. So this one sounds really nice, right? It must be pretty easy to write services when I got these really strong platforms. By the way, for you guys, Java developers, these platforms are really monsters. Think of that this one here for caching and working with database here might be Hibernate, and this one was JMS. And there's huge APIs and standards that come out of the box with the installation. So what's so wrong about it? Well, I'll tell you what's wrong about it. Let's talk about Netflix for getting the picture, okay? So I'm doing a little takeoff of Netflix business, but it will get you going, let you understand the problem with this architecture, okay? Why was it good 20 years for the last 2 decades, and suddenly it really crashes? It doesn't really manageable in some cases. Why? So the story basically of Netflix starts with VOD services, right? But think of it that Netflix used JE services in order to provide us with some, movies. So here are the movies. Let's paint them. Here's one movie, and there's another one, and there's another one. Now, a long time, they've seen that there are some movies that are pretty popular compared to others. Means that most of the server is working on servicing this movie. It works on this one a little, and on this one a little, but this one is a star, okay? So what do we do? Now the server is really starting to work hard, a little smoke. What do? Well, we open another one. Okay, so we open another one. So we've got those 3 replicas all over again, right? That we just painted. So we've got the popular movie, and we've got this movie, and we've got this movie. And once again, since we opened another instance for this one, we get this, okay? Now, since those 2 movies are not popular, don't expect to get calls here. It won't happen. No one needs it. Okay, now I'll tell you the end of the story, okay? Because what you see here are 2 instances, right? These are 2 servers. Now, end of the story on Netflix is, listen to that. Okay, this is the end of the story. And when you talk Netflix today, we are talking about 4,000 instances of servers on Amazon, which is a really not cheap provider. So I ask you, would you like to run 4,000 replicas of these and pay the money multiplied by 4,000 at the end of the month on electricity that you used but never paid you money? Does it make sense? Well, this is what happened to Netflix. And how do they solve that? Well, they say first, no more with those. Can't do anymore. It's too heavy. I'm running too much stuff I might not need or use. And multiplied by so many, it becomes a monolithic, expensive deployment. So what do we do? Well, let me just close down my email so it won't make any noises. So what do? Well, their solution was to move into something we call today microservices. Okay, so they simply break down those movies. Okay, it's not necessarily movies; it was really services. But I told you I will take off on their product just to let you understand. And we'll put the popular movie here, and the other two I will put here. Okay. Now, when we get lots of requests, lots of them, and this one starts to, run a little heavy and raise some smoke, then all we have to do is simply open more of this one. Just this one. Because just this one makes it worth because it makes me money. Okay? So basically, bottom line is that what we do today is probably decompose applications for accurate orchestration. This is the bottom line here, okay? Because there's not really a real good reason to decompose my application into small units that are maintained separately. It raises some challenges, right? But to enjoy this saving electricity, be able to use exactly what I need. Because in big data, there's no other choice. So the enemy here is big data. Before big data, JE and .NET were great, but big data forces us to do some accurate scaling. So basically, we call it microservices today. And really, Netflix is the one that invented it. So chapeau. But wait a second. I'm going to show you something really nasty about Netflix later, and the solution for this nasty stuff. So they did good, but there's something they do really, really bad later on. Let me go back to the presentation. So if we'll take a look at it, let me just enlarge it once again. I hope you see it now. So we are basically moving from monolithic domains into microservices. And as you can see at the bottom of it, I put two words that are pretty popular today, right? DevOps and full stack. Now, these two really highly requested professions today are existing basically just because of big data and microservices. There is no other reason for them to exist. And I'll explain, okay? When you decompose your application into microservices, you basically break it down to small software units, okay? Under some use case agenda, or as I said, accurate orchestration thinking, okay? Now, when we do that, we basically have to take care as the developer, in some cases, for everything. If I write a microservice that have to grow or provide some user interface, then do some calculation with the input and store it in some in-memory database, then I probably should know about user interface and front-end, integration and REST, and also storage and in-memory calculations, right? So, well, I cannot say that I'm just a backend developer. I'm now a full stack developer, and more than that, I'll have probably to wrap it in some really nice and easy to use way, so it can be easily be connected with all the other microservices. So I have to know a thing or two about platforms. So it's not like classic developers, for example, in some, I don't know, fintech huge bank that the employee that employs something like thousands of backend developers, all are doing everything with regulations and fintech basically. This is their expertise. They know nothing about front end. Okay? So now these guys are pretty much less relevant for microservices, because microservice developer has to be a full stack developer that knows how to provide solutions end to end, but small, okay? We cannot provide end-to-end solutions to a monolithic system, right? Now, guys, just pay attention that you're not muted. We've got some background noise, so please make sure that you're not. And you can obviously open your microphones if you've got questions you want to ask me, please. Feel free to do that. Now, the other part is DevOps on the other side. Now, what is DevOps? So basically, if I just told you that Netflix runs something like a few 100,000 instances on Amazon, well, who's the one responsible to shut them down or start them up when needed? Who is just this genius? And tell me, at night, does he sleeps? So basically, it's not a human, right? It's something that should be automated. This orchestration must be automated. So I won't first you with more technologies on DevOps, but today the new kings in town to do that are Docker and Kubernetes. These are the two most popular things that we use under open source platforms, or simply as open source as is, to allow us come up with such solutions of automated orchestration. Docker allows you to start and stop services. Kubernetes decides when and how and what actually the orchestration policy is. And both, they do that. Now, if you pay attention to this slide, decomposing for accurate orchestration is something I mentioned, but there's another thing here, extreme agile. So this is something we see a long time. No one really, thought about it in advance. Okay, this is not the main reason why microservices exist, but this is something that occurs since we've got this architecture and method of development. Extreme agile means that today we have to really move fast with our services and products. And by that, I mean, I always give this example of iPhone, okay? iPhone is really popular product. I know that because I purchased one I won't tell you every how much time, okay? Because I'm really ashamed of that. And this is the point. I can tell you that Apple know or had the prototype of iPhone X something like 7 years ago. Okay, it makes sense. But you didn't see this prototype out in the open, and you weren't able to purchase this iPhone X 7 years ago. So why is that? Well, the real reason is that because they sold some few devices in between, if you remember. There was iPhone 4 and then 4S and then 5 and 5S and then 6 and then 6S and go on, go on. Bottom line is that you saw every something like 9 months, people standing in lines to get the new iPhone, okay? Now this is not the final prototype, but it really makes a lot of money, doesn't it? So instead of selling you something amazing 7 years ago and wondering 7 years after why no one is talking about me, I will sell it to you in pieces. I will sell it to you in pieces. I will sell it to you in versions, and you will talk about me all the time. You will also pay me dearly for this. So this is how economics moves. And talking about services, not just hardware, it means that every time the developer is being asked to add another service, another something, logic that we didn't have before. So we can resell it. So people will talk about us. So we will remain relevant. So now let's take it to the technical part. It means that I, as a developer, have to come up with new releases all the time. Those releases must be checked, tested. They have to be version controlled, because if they are released and did some damage, we have to roll back the release. And then they have to be packed and deployed to our services. Then we have to use some feedback engine to see how it works and decide on our next features. All this cannot be done in the manual agile way. So agile is not enough. Iterations are not enough. We need some platform to, take this piece of code, automatically test it, automatically pack it, automatically manage its version and deploy it and publish it, and then respond with those feedbacks back. We need to automate all this process. DevOps is mostly, it's partially about this. So another reason for me to go and decompose, or not necessarily decompose, but add some new features to my monolithic domains is simply by adding them as microservices. Instead of taking down the whole system just to add some code, add the code as a microservice that interacts with your system. Keep all up. So this is what's happening now. We are partially shifting or totally shifting, or obviously there are some of us that are not shifting at all, into this new neat architecture. Another thing we have to be aware of, okay? We are now started with some requirements for what's known as platform automation. And this is something really important because you know what? It makes you really addicted. And by that, I say that there's several ways to decompose your application or to expand it with microservices, okay? And we'll see exactly how it can be done. Now, as you can see, there's already this evolution, serverless. Now, serverless is something that is really not the future. It's happening. It is well supported. But what does it mean? Serverless basically means that you take your code and decompose it even more. If we used to think on microservices as pieces of code that holds lots of functions, which has some orientation, and this is why when some of them work hard, the other work hard. So we took all those functions and we simply placed them as simple unit, decomposed, and call it microservice. But here we go to the extreme. Here we go and take one single function and we give it its own orchestration management. So here we decompose into functions, not into logical services, okay? Now, the point here is to really do it in the most accurate way. In these scenarios, we say that we really want to develop functions at all, and their interaction will cause them to work harder or less hard, and we count on some amazing platform to know how instances of each server carrying each method, each function, should be up and running to save us money, okay? So let's say, guys, that let's keep this one because part of our big data implementations in our organizations probably might be using these accuracy in few years from now. And I want to tell you why I'm saying few years from now, because we are at the beginning of a really, really amazing revolution, okay? Some people tend to think that this is what we do today, surf the internet and use our mobiles, this is the internet. Well, no, this is just the beginning. This is even not close to what the internet is about to be. Just to give you numbers, if you think of it, every person in the Western world is holding basically two imaginary connections to the internet. The first one is my mobile phone, and the second one is my PC or laptop or tablet or whatever. So let's say that in average, each Western world person holds two communications to the internet. But if you count IoT, then we're talking about a world that in 5 or 7 years from here top, we are about to hold something like 5 connections each to the internet. It will be our watch, some biological sensor that someone planted in us. It might be our IDs that are provided by the country. It might be even our clothes and some gadget that holds and monitor our health. All these are tweeting informations to our doctors or maybe doctor bots. I don't know about it, but these are much more lines transferring much more data over the web. So what we do now is really just the beginning. So don't think that you won't be wondering about coming up with these accuracies. But here, there's a problem. Not everything is so sweet. If you see the word cloud here, then how do we get these platforms? Do we want to, establish it by our own and employ DevOps engineers? And how expertise we have to hold in order to gain such amazing deployments platforms as serverless, which knows how to do some accuracy on how many instances runs each function and even provide some machine learning capabilities inside it, so the orchestration will be intelligent a long time. So will you really build all this by yourself? Okay, what about your product? Remember this one? It's a whole world of expertise. So what do we do? Okay, we'll be back for this in a moment, but as you can see here, we've got some slide about automated platforms and go both ways. We have to provide some solutions to this decomposed way of development, and we also need to come up with some accurate orchestration platforms. So we can do it by ourselves by using open source tools. Docker Kubernetes means you have to purchase knowledge, employee DevOps engineers, or you can simply use products and pay for support or for license. So this is the actual real dilemma, right? Nothing changes in this scenario, or maybe it is. So let's see. I talked about cloud and mentioned that as being more relevant from two reasons. Okay, one is probably known. As we shift to big data, we need more and more platform which can be dynamic, because I cannot run with 100% production every time. If I sell a huge amount on Black Friday, it doesn't necessarily mean that I sell the same amount all the other days on the rest of the year. So there's no point in running such an amount of servers or instances. So this is why we tend to shift into dynamic platforms. So if we shift from domains, which are not dynamic at all, I can say to you that the largest cluster domain I ever heard about, not so, heard about, had 165 instances. More than that, licenses are pretty much really costly for you to own. So we shift into virtual platforms that actually provides us some machines which are virtualized over hardware, and this is how we can control our licensing and computation power, and it can be adjusted according to our use. So here come the big questions. Do we create our own private cloud? Means that we purchase all those computers and provide the network and then employ the DevOps engineers to come up with all these setups for accurate configuration and orchestration? Do we simply hire those services from some public clouds like Amazon or Azure or Google or many other more and pay money for that? Here we pay money and also have to gain some knowledge about administrating such platforms, because we really don't want to run something multiplied by many on AWS just because you made a mistake, because you have to pay for it. No one will ever give you some discount on electricity that have been done already. So you will have to pay for your mistake dearly. But it's still much more cheaper than construct ones on your own, okay? Now, in which you can pay for both. Now, another way to go is to do some hybrid cloud computing, which means that we actually combine the two, okay? Some services are developed and deployed on some small private cloud. Probably major reason to do that is security services, privacy services, and many other reasons which are really irrelevant because the public cloud gives you much more privacy and security, but it's okay. It will take us time to get know and actually recognize that this is what's happening. But basically, today there's another reason, and it is the bandwidth. If the data center, public data center is really far away, then in some cases I need the performance and I have no other option but to use some local services, and if there aren't any, I construct some myself. So it's really costly and painful, but sometimes there's no way to go. But once again, if you think of what's happening, data centers are actually popping up like mushrooms after the rain. So because they made money out of it. So every place in the world will have its own several data centers eventually, and location will not be a good reason to avoid it anymore. So here goes another reason why not to stay with private clouds a long time. Now, is it the end of it? Because a long time we'll pay dearly for our private clouds, and services on public cloud will get rich and enriched all the time. By the way, they collect information about us, so they can do a hell of machine learning services much better than we can come up with our clients because just they got so much more data. So eventually their software as a service will probably in most cases will win ours and will be cheaper. So is it a dead end here? Is it once again the vendor locking story that once we found ourselves locked in on JE or on .NET, and now we find ourselves locked on AWS, Azure? Are these the new king in town? Well, no. And I say no because we've got something really, really neat, which called decentralized clouds. And I will talk about this one at the end of my presentation here, because this part is the innovative part. It's not science fiction. It's happening. There are startups already, but you see it's pretty innovative because no one really comes with such a solution till now. Now, let's pause with clouds and microservices. I want to take you to another direction, totally different. I told you that Netflix did a great thing, right? And the great thing she did was to decompose in cases of requirements in accurate orchestration. It did good. They made a lot of money. Their scale is amazing. So this is a success when it comes to software architecture for big data. Now, but there's the ugly part. And I would like you to see this ugly part. Let's see it with our own eyes. I will stop share right now, do it right. So let's ask the server to provide us with some information. For example, I will ask the server to provide me with, let's say, all the let me just show it to you once again here. I would like it to show it to me, all the lines from line 10, the 10th line, so it starts with 9, till line 20, and I would like it to stream it to me 2 seconds delay between each. So as you can see, now we stream the movie, we stream the book from the 10th line to the 20, and now it will stop. You see that? But pay attention to the magic. Pay attention to the magic. It all happened in a single response. There's no wrapping between each event you got. Basically, what I did here is used HTTP streaming to simply keep you on the same connection, on the same response events. This saves you from refreshing all the time, and this saves me a lot of bandwidth. And by the way, by the time we talk, I asked this talking guy to go on and talk about the movie, about the book. And right now, when I'm talking to you and run the server, talking is actually reading the book live. Do you want to join the live session? So let's do it. Here, what we got is the 3 last live last lines read by talking. And here comes the last three again. So basically, what I can show you here is that we can stream data. But see that I can stream a lot of data, endless data. Let's take this and let it do 100, or let me give 5 seconds, or maybe 100 millis between each line. So now we get it, but it's the same response, just like the movie. You can see that. I really save a lot of data right now, and you can read. If you read fast, it keeps on coming. So there is a solution, and let me just take you back to the slides here, okay? And talk about this solution for a second. Okay, here goes. So basically, what we do is shifting from some really problematic situation in which we used MVC. And by the way, I'm not telling you that MVC is dying. I'm telling you that in some cases, MVC might be problematic, so you should think about reactive. So here we get the MVC way of life. The view asks the controller uses a thread, this thread goes to the model and do its job. Then it goes back to the response, and when the thread goes back to its home, only then we can treat another request. So we suffer from back pressure. In this case, if there's 3 clients that want to see a movie for 1 hour and a half, then probably the fourth one is not going to get nothing but timeout because there's no one to serve it. Instead of that, the reactor design pattern simply uses asynchronous channel and data streaming. In this case, the client asks from the reactor to watch a movie. Reactor simply throws the client's connection to the right worker threads that plays the movie. So let's say that now we place the model 2, movie 2, okay? And right on, the web reactor is available to accept more requests. So basically, the web reactor never blocks. Always get requests and throw them over the fence to get treated. Now, the point here that those workers behind the fence got the connection. So they stream the video straight to you. And those threads share execution. There's no minutes in runtime that one thread joins a simple specific client for more than several nanoseconds. So basically all threads share the streaming to the clients among them. So it's quite like execution slicing. So they all get it at once. And this is an amazing model. I will not spend more time talking about it because it's really going deep dive inside thread model, but I can tell you that I will be happy to provide you some full courses about reactive programming and reactive REST services and even reactive NoSQL. I'm going to talk about this architecture a little bit more when we talk about no cache applications, but basically this is a really neat and beautiful thread model that allows you to stream data and handle a lot of long-living requests with very high concurrencies with few threads. If you ask yourself why PHP is going down and Node.js and Spring Boot and .NET Core are the new king in town, well, part of it is their supporting in reactive platforms. Let's move on. No cache. Let's talk about this one a little, okay? As you probably think or used, since databases are basically files, reading from databases are usually pretty expensive, and the price becomes really precious, costly, as we shift to big data, because we have more data. So what do we do? Well, today what we do is use some really nice stuff which is in-memory solutions. So we take some byte from the database, the RDBMS, just like we do by taking bytes of data from third parties. We cache them and we maintain some really advanced cache mechanisms in order to optimize what to keep and how much time to keep it. Now, what if I tell you that there's another new era that is starting to be seen, okay, when it comes to databases? And what if I tell you that there are databases that are capable of working as fast as your RAM? They run as fast as your in-memory cache processors. Well, first, it's not science fiction, since both RAM and your modern disks can use flash technology, right? So I know that today, if you'd like to purchase from public clouds like Amazon or Bluemix or others, flash machines, it will be pretty costly. But let me tell you this. When you do that, there's some databases, one of them is mentioned here, Aerospike, which are pretty new, and you should read about it, because what they do is simply offer you drivers that are accurate match to your flash chosen drivers. So basically, they do two amazing things. The first thing is simply being NoSQL database. They basically work in key value, which is a really fast way of approaching data in data structures, right? Map, hash codes and stuff. And the other expertise is that it can be configured with the exact matching flash hardware drivers to meet the performance of almost RAM. And now let me ask you, do you need cache, in-memory cache, products like Redis and Spark, if you can simply go to the database as much as fast? Well, no, you don't. You can simply go to the disk. And by the way, I'm not saying that we don't need cache at all. I'm just saying that today, everything that is stored on RDBMS or NoSQL databases like Mongo and stuff, well, we should think again, because there's things that can simply provide you data, less structured, but still data, so much faster and so much easier that you won't have to spend your time and efforts on in-memory solutions, because it will simply work as fast as your RAM. It's as fast as it can get. So read about it. It's pretty interesting. Okay, now, short thing about artificial intelligence and machine learning. Not much to say about it, because there's a shift lately from what we know called neuron networks to what's called today deep learning, and eventually this will be the end of the story, because as you think of it, we are drowned with data, so there's no way we can even, in some point in the future, it will be really hard for us to do some supervised learning, because we cannot supervise the data anymore. So supervision will be done by other machines. So this machine learning is rapidly construct some internal solutions which expressed eventually as software as a service. And let me just explain what I mean by that, okay? Today, when I want to create some machine learning-based development, I will have to employ some machine learning engineers, which are today currently mostly workers in the automated professions, right? Because they used to do some business analysis and some highly complex statistical programming, and today most of them want to do machine learning. So it's a pretty natural evolution here. But since they're really costly, and there are some platforms that really enjoy huge amount of data. The trend is to take this knowledge and turn it into a machine learning as a service. I'll give you an example, okay? Today you can use some really nice function. By the way, it's a function as a service. So the more you use it, the more instances are running. On Bluemix, the IBM cloud, that allows you to send a picture and you will get back a JSON that details what's inside this picture. Now, you can guess how much it costs you, right? $0. So think of it that this is really well, today, picture recognition is a common machine learning today, right? It's really a common service. But why shouldn't it be with more complex services? They will be common as well. So you can pay attention to the number which I saw in few article about it that I read about the future of machine learning and data scientists. And you can see that there's a really dramatic growth expectations towards 2024. We're talking about almost 1/4 of growth when you compare it for today of machine learning as a service on public cloud platforms. It means two things, okay? That the data scientists will be less required than today for inside hiring, I mean, because public vendors will need them dearly, and that most of the really highly developments today are going to be served as a service, pay as use in the near future. It's not much time. So lots to wait to. Now, another really cool thing that I would like to discuss here, and it's really one of the deep technologies which are game changers, is blockchain. So let's see the trend here, okay, the path we go. And then we'll understand a bit how blockchain works and why is it so different than what we already have compared to what. And then we'll probably be able to understand the revolution it offers and why it is so, well, let's say, we talk about it all the time, okay? And billions of dollars are now held inside blockchain-based platforms. So we have to talk about it. Something is happening. So first, let's talk about the situation right now, okay? And the situation right now is mostly centralized systems. And as you can see, when we talk about social networks, well, when you are a Facebook member, every post of you goes through Facebook servers, no matter what you do, okay? And as you know, some of those posts you even didn't post them. They simply gone behind your nose, so you didn't even know, okay? So it is centralized. They want to know about you. Let's take those visas and all these online paying services, okay? When you get a credit card and you use it, well, you pay your commission to the Visa company, and if you purchase from Amazon, for example, then Amazon pay also to Visa for this transaction. Why so? Why is that? Well, this is because Visa is responsible to say that I am I and that AWS is AWS. And this is I can be sure that I'm paying the one I'm asking to pay for. And they can be sure that they are getting the money from the one that says he's paying to them. So I need Visa to approve both sides. What about court? When I want to use court services, I have to go to my country to get them. I cannot use any court services of other country, and they cannot be outsourced, right? Same goes to finance. When I want to withdraw money from the bank, if it is a lot of money, the bank which keeps my money is allowed to ask me what for, and even allowed to say to me, I'm not letting you take this money for this purpose, even though it is yours and you are paying for us to keep it there. This is how economy works. So these are all centralized systems. Now, you probably think that I have a lot of critics about it, but I want to say to you, no. Today, as things are, there is no other way, and we have to be centralized because those systems, maybe Facebook is not part of it, but all those systems like Visa and courts and financial services really keeps us from frauds and from ourselves. Okay? So we have some problem, then we can turn to someone. I don't know if it can help me, but at least I have someone to go to. Maybe it will help me. So it's something. There is someone to talk to when you are in trouble. Now, another thing that is happening today is decentralized system, but as you can see, it happening in two areas: low tech and, well, alternative economy. I don't want to call it like that because today there's no regulation there, so I don't know how to treat this thing, but it's really, really got us talking about a blockchain. I'm talking about currency and cryptocurrency. So let me spend some few words on blockchain so you just to understand what's so special about it. Okay? I'll go to the whiteboard for a second. And when we talk about blockchain, we really talk about database. So now you think, oh, it's boring database. No, it's not boring. It's really, really, really cool thing. Pay attention to what. This database is really something we never had before. It has some characteristics that I'm going to list to you right now, and you will see that it's really, really different. One, everything is an insert, add. We cannot do update. No updates. Another thing, it is encrypted. So no one can see what's happening inside. And encrypted, sorry, I wrote right, encrypted. And another thing is that uses consensus make decision. And this is really, really cool. Let me just explain, okay? What happens in blockchain is that there's two participants in that kind of database, okay? And the goal in database is to simply hold data, right? So remember this one. But pay attention to how this works. We've got simply two kinds of users. First user are validators. Let's paint them as stars. All validators are maintain some internal network and can talk with themselves and between themselves. And there are us, the clients. Clients want to transfer data from one another. So let's do it easy and say that one client wants to transfer data, means bitcoins, for example, to another client. Okay? So what we do is actually notify the validator that we would like to do some transaction. What happens now is that all the validators, those stars, has to take an individual decision regarding our transaction, whether they approve it or not. So let's think about this scenario in which this validator here says, oh, I know this guy, and I take a look at its wallet and I see there's money there, so I vote that I approve. This one does the same, and this one does the same. So it goes about this one and this one, and in this moment, guys, I've got my majority. You can see I got a consensus. Most of the validators decide that I'm allowed to do the transaction. So what happens now is two things. First, they write a transaction inside a block. So they hold some block. Each validator has its copy, and they simply put this transaction inside a block. Okay, trying to do it now. Here goes. Okay, I put it inside a block, and then transaction actually
curse, and this guy gets the money. Now, eventually, as you can probably guess, these blocks will be filled with transactions, right here. You can see it, so it will be filled with transactions. Here comes another dramatic part in which one of the validators is chosen, okay, let's say this one, to take this new complete block that we've made and add it to the blockchain. It simply binds it in an encrypted way with all the other blockchain we already have, okay? So now you can say that in this critical moment, when one of the validator gets the chance to update the actual data, this is when it can hack and put some bitcoins to itself, right? Here's the place when we can cheat. Well, not exactly. I'm not going to step deeper into this, but basically there's two genius mechanisms. One called proof of work, means that in order for you to be the chosen one that seals the block and adds the data, we want you to do some guessing and solve some riddle. And this riddle will require you to pay a lot of money on computing in order to solve it. But if you solve it, then you will get the chance to be the one that seals the block and get a really good commission for that, a lot of money. Just to give you in sync, to get you in sync, in Bitcoin, you will get something like 11 bits today, which worth something like $19,000 if you will be the chosen one. So you should probably think, okay, I should buy a lot of computers and start guessing those riddles so I will get the commission. Well, this is the reason why a lot of computation goes and a lot of electricity spends to do some decision making on the blockchain, and this is not good, of course. So another way to do that is simply to random pick up some a validator, not let them fight on this, just pick up some random one. It's called proof of stake. And in order for you to be the one that is chosen, you will have to risk some of your money and funds. So if you cheat, you will lose those funds. And of course, those risks reaches millions of dollars. So you probably won't cheat. Now, it's really cool, but let's go back with this story about this neat database that simply gather data, and what's so special about it? Why is it so special? Why it really has the potential to be a game changer? Well, pay attention to what we just saw. If there's no updates, then it means that reality is counted according to whatever happened through history, right? Well, if so, it's really, really, really secured, because the amount of bits I got is the amount of everything I done since I joined the network. It's the total sum, right? So this is something that really cool, because I don't know if you know that, but if you go to your bank and you withdraw some money, let's say we've got some $100, okay? And now I withdraw $50, okay? So now they made some update on the table, right? And they say now that I've got $50. Now the problem is that I just thought that I never got the money. It got stuck in the machine, okay? Now you have to go and use some backlog transaction to see that the data, the reality was now erased. This is what happened with update. Now in blockchain will have never happen. It is recorded there. No one overwrites it. So update is really, really risky when there's centralized systems and they make mistakes, because you cannot prove anything and you've got really problem to get your assets like that. Encrypted, it's strongly encrypted. Uses consensus, this is amazing, because how can you hack to such system? In order for me to hack the system, let's say that I want to now do something really bad and transfer a lot of money to myself, which is here in another identity, but I would like to transfer a lot of money that I don't have. Obviously, I know that these guys are going to say no, no, no. But if I will hack them and convince them to say yes, I might do that, right? Well, no, because there's millions of them and they connect and disconnect as we speak. So you will have to hack to millions of applications. It will not be worth the efforts and the amount of assets you can eventually steal. So basically, it's really hard to hack. Now, after saying this, let's go back to the presentation for a second. And we can see something really neat, because right now, we can, wait a second, sorry, wait a second, here, okay. We can see that the chain supply and the diamond industry uses blockchain. You know what they do with it? Well, when we ship something, so all these packaging is documented on the blockchain database, and when ships carry it and stops in some places along the world, it is being stamped. So when it reaches me, I can know exactly in which stations this product or shipment gone through, because I have to pay for this shipment and the fees, okay? So it's really important, and there's a lot of money there, and no one wants you to put some, incorrect data and not pay, or pay more than you need. So it is maintained currently, some of it, on blockchain. And what about diamonds? If you create a diamond in the laboratory, or if you mine it, it is documented today in diamond's blockchain. And when you get yourself a diamond, in some cases, it depends where you purchase it, you can see its transitions from the minute it was created or mined through all the hands that actually traded it until it reaches yours. So it is all documented. You can make sure, for example, this is not a blood diamond as you go through its history. Now, if you think about it, it's really hard for us to imagine banks or lawyers or those visas becomes decentralized. But why not? Think of banks. If you want to transfer money, your bank is not the only decision maker. It has to be a consensus of several banks. Each has its own history about you. So each can make its own individual decision about you. And the consensus will determine eventually if you are allowed to do the money transfer or not. It's more democratic. It's less centralized. Now, same goes about Visa, which is really funny. If I want to transfer money to Amazon, I need them to say that I am what I claim to be and that Amazon is what it claimed to be. How about the network to vote about it? And then we don't need them and we don't need to pay those fees. What about this? So basically, when you think about it, we can pay much less money for decentralized services just because there's no someone in the middle that rips us off because he can, because he wants, and sometimes because he's forced to spend a lot of money itself on security. Everyone wants to hack those centralized systems. How can it be hacked if it will be decentralized? So it's quite interesting. And if you take it one step further, distributed systems means that the vendors are us. And let's take this one step further. I'm going back in the presentation just for a second to this slide. We saw that already. Decentralized cloud. Let's go on with this idea for a second, okay? How about this? Instead of deploying everything on Amazon and all its costly friends, how about this? We will be able to use our devices. We will contribute some percentage of their processing capability and their memory. We will contribute it to the universe. We will become some huge contributor network, and we will be also the clients of those networks. We will provide computing power, and we will use some services on that platform. Now, at the end of the month, you will get the bill. The bill would say you contributed this amount of calculation power, and this is why we pay you X. And you used for services this amount of services, so you have to pay Y. And your profit is obviously X minus Y. Means that your devices, your computers can be the future cloud. Some of it. You know what? This is how we mapped the human genome, right? We had some screensaver that allow the application to use some percentage of our machine, and this is how they gain some power to map the genome, right? So why don't we use that for our clouds? And it doesn't have to be ended with clouds. It can be basically everything. Okay, so this is really nice a step. And by the way, as I say, it is innovative, but it is far from being science fiction. It is already happening, and there are some startups that are dealing with those decentralized blockchain-based platforms. Now, last slide here is all about deep techs. Deep techs are all the technologies that are about to become game changers. And if we go through them, then artificial intelligence are really about to change the way we do decision making. And there are big, big questions about as humans, our place in the evolution. Some says, and if you think about, it's not far-fetched, that we are now constructing the next evolutionary generation, and it will be some cyber humans or even bots that don't need humans at all. So it's quite amazing what's going on here. And in some areas, I can say to you that I was putting my hands on writing some commercial robots for forex and trading and all this e-trading. And I can say to you that this world is almost totally occupied by bots, and you can never know as a human if dollar is about to be stronger according to euro without using bots. Okay, there's no person on earth that can do that because it's too much information. Oh yeah, and by the way, bots are playing with this information, purchase and buy and play with the graphs. So let's try to win them. No chance. So it's happening in many places, in many fields today. Robotics, of course. Robotics can do a great change in actually being first replacing our low-tech jobs, and of course nanotechnology and all this stuff that can actually fix us within ourselves and do amazing stuff. So I can leave it to the imagine what can be done there. Blockchain. I talked about blockchain, advanced material science that I don't know much about, but really revolutionary. Photonics or solar, which might be a game changer in energy consumption and really lowering prices of computing today. Biotech, and of course quantum computing. Quantum computing is one hell of amazing thing, and when this thing is out and open, we are going to get some huge scale in computing power and speed you hardly can imagine. Just to give you the scale of it, if today it takes us something like 80 million years to crack the strongest standard in the market for decrypted the messaging, asynchronous messaging, then quantum computing is about to crack this one in 4 minutes. And the reason it does it is because it uses electrons rather than electricity or light, because electricity or lights are binary. There is electricity or no, there is light or there is not. Quantum computing counts on electron. Electron can be both on and off at the same time. So the idea behind quantum computing is to run endless algorithms and pay the price, get all possible results, and paying the price of single execution, which is quite amazing. So it is going to beat conventional computing, and there's a lot of algorithms working done. Most of it, by the way, in the encryption and security stuff that will have to get implemented from scratch by the time computing machines will be available products. And once again, this is no science fiction. They are already, but they are not commercial. It will be. Okay, so this is basically the end of our lecture. And I really hope that you first enjoyed it and that it was innovative to you. And once again, I gave you my name and email. If not just that, if you would like to hear more about some of the topics I mentioned here in this lecture, then it will be great if you send me your emails and I will see how we can help you with that. And more than that, it is all recorded. I'm now turning back the video just because before saying bye-bye to everybody. So it is recorded and it will be available to you from a few hours from now. I'm pretty sure it is sent to you. So I really hope you enjoyed it. Have a great weekend and good luck with new technologies.
Thank you a lot. It was great.
Thank you. Thank you very much.
Tony, thank you.
Thank you. Thank you, guys.
Thank you. Bye-bye.
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 Thank
Bye.
you.
Thank you.
Thank you.
ביי, תודה.
Bye. תודה לכם.
תודה רבה.
Bye.
Bye-bye.
Have a great weekend. Bye bye.
Thanks,
You too,
Roni.
guys.
Great webinar.
Shabbat shalom, Roni. Bye.
Thank you all. Thank you all.
Bye bye.
Bye-bye.
Bye.
You can stop the recording, Roni.
Yeah, I do that before I go down. Okay. יאללה.
After that, we need to cut
חבר'ה,
it.
תהנו.
תודה, רוני, על הכל, יקירי. תודה על הכל.
חבר'ה, בכיף מתי שתרצו. בכיף.
תודה, ביי ביי.
ביי.